Okay, thank you, Kristen, and it's great to be with you this morning. This presentation has come with some co-benefits in that I got to come to my office this morning. I had the privilege of riding to work in -15 today, so something different for a change. Um, I'll talk about climate risk and scenarios. Just to give you a quick idea of what I'll talk about, I'll just touch on the sort of scenarios that are out there. Then I'll try and simplify things and talk a little bit about transition risk and physical risk. Touch on COVID-19, what happened last year, and different scenarios going out to net zero, 1.5 degree scenarios, and so on, and finish up with an example of oil. So there's essentially a plethora of scenarios out there. This term's come from a report that we use, but I think it's quite an appropriate term. So if we look at a figure of scenarios, it will look some spaghetti plot like this. And when institutions, organizations, businesses are asked to assess their climate risk, they're asked, and I sort of quote, to take in consideration a range of different climate-related scenarios, including a 2-degree or lower scenario. So on the screen here, these are the sort of scenarios you need to take into consideration. So which scenarios do I use out of this? How do I select these scenarios and so on? It's not an easy task. This figure shows scenarios going out to 2100, which is a very long way into the future. Many are interested in what's going to happen, next year, even this year, 2025, 2030, 2100 gets very abstract, but this is what scenario is essentially designed for. This figure shows carbon dioxide emissions, which are very important, but it's a very aggregated indicator. Some people may be interested in energy, some may be interested in coal, some may be interested in batteries or electric vehicles, and scenarios go into more or less detail on some of these sort of factors. So you need to sort of make a choice and simplify out of these scenarios, which is a first big challenge. Just to tell a little bit more simpler story about transition risk and physical risk. So if I take those scenarios from the previous slide and I've simplified them here, I've put them into groups and averaged them. And so there's 6 different lines on this figure, which are just illustrative to show what's happening. This figure here is CO2 emissions. Up the top there, you have a scenario if we don't really have any climate policy at all and just keep burning carbon. And on the bottom in the purple, there is a scenario which would keep us, below 1.5 degrees in that territory. So this is a figure showing the temperature response from those scenarios. So as I was saying, high end might go up to 4 degrees at the end of the century, low end, maybe we can keep below 1.5 degrees. And the left-hand side, the CO2 essentially gets into transition risk. So that's the risk that we may face if policies come in faster than we expect, technology changes faster than we expect, maybe society changes faster than we expect as well. And physical risk starts to relate back to damages that we may face from, let's say, storms or sea level rise and so on. One very important thing that we sometimes tend to forget is that climate impacts are actually happening right now. So global temperatures are around about 1.2 degrees. This arrow on the figures here points to 2030, and around 2030, give or take a few years, uncertainty and so on, we'll hit 1.5 degrees around 2030. That's almost a given. If you look on the left there, the arrow on 2030, you see the scenarios have diverged quite a lot by that time. So a baseline scenario compared to 1.5 degree scenarios are extremely different pathways. But because of the slow processes in the climate system, the ocean heating slowly and so on, all those scenarios end up with around about the same impacts in 1.5 degrees. There are reasons that you would mitigate anyway. There are changes in rates of change and so on and so forth, but the big benefits come later. So if you move to the right on these figures, the temperature is much lower if we mitigate now compared to if we continue emitting a lot of emissions. So that's a first key challenge, is the inertia and slow timescales in these systems. We have to act now to get the benefits later. When thinking about risk, it's useful to think about where we're actually heading. So if you look at current policies, that are sort of implemented. If you look at policies that may come in very soon, almost legislated, if you like, most analysts would say that will probably peak emissions in the next at least 10 years or so. Some say we've already peaked emissions. And then after that, moving 2050 and beyond, it's a little bit harder to say where emissions will be. Maybe they'll be flat, maybe they'll go down. But this black line I've drawn here is somewhat representative of where emissions are sort of heading based on our actions currently at the moment, and if they sort of continue with some similar level of ambition. Now that would give us, in this particular example, around about 2.7 degrees of warming towards the end of the century, which is not a good outcome. But it's just saying current policies are taking us in this territory, let's say 2.5, 3 degrees, maybe over 3 degrees, but it's not taking us to 4 degrees or 5 degrees or something like that. And it's not taking us to 1.5 or 2 degrees. So once we can sort of establish where we might be heading, we can think about the gains that we want to make. So if we mitigate more now, we'll have lower risk of events in the future. They'll be less extreme and so on and so forth. So what we want to do is to shift this curve down. And this is where we get the transition risk. So maybe governments will act faster than some have expected. Maybe technology will come on much faster than many have expected. And this is a big risk at the moment, I think. And maybe society will change its preference. So these are all risks that are out there. Things could go worse, and this is where physical risks become more of an issue. So we do have climate change already, and we're going to get more climate change, so we still need to assess physical risk. But maybe emissions don't go down as much as we'd like. Maybe there's some nasty feedbacks in the system, and so maybe we end up with higher end events. So we still need to explore these high risk events at the top of the curve here. There are a risk that they can be realized. So that sort of tries to summarize the physical risks and transition risks. Just another way of expressing this. It's a different figure, so a bit of shifting around here. This shows a probability distribution, straight down the middle here. Is sort of the current policy outcome might take us to, let's say, 2.5 or 3 degrees. So the physical risks, we're particularly concerned about cases where we shift in the direction of that red arrow. So emissions don't go down fast enough, technology doesn't go as well as we like, I don't know, public resistance or feedbacks in the climate system and so on. And where we want to go is to the green arrow, but then we face transition risks. Governments might act fast, technology might change fast, society might change fast, and this could bring additional risk. So moving on, just want to touch on COVID-19 and pathways moving forward. This figure here shows a figure from the International Energy Agency. Well, actually, the data is from the International Energy Agency, World Energy Outlook. I've constructed this figure here, but if you look at the black line there, that's history. That's what's happened already. And if you look at the end of the black line, you see a dip. That's 2020. So the IEA and others have estimated around about a 7% drop in emissions in 2020, which is a very significant drop. But if you look at the blue line, which is the stated policies from the IEA, so this is what happens if you assume that the current policies and policies are soon to be implemented continue, then the IEA will see a rebound. Emissions will go back up a little bit, I suspect maybe faster than the IEA has here, but then level out. So this is agreeing with what many analysts say, that we're sort of getting close to peak emissions. However, if we want to keep well below 2 degrees, then we need to be going towards these green lines here, which are pretty radical changes. So the light green line is sort of 1.7, 1.8 degrees, the sustainable development scenario from the IEA. The dark green line is a new scenario from the IEA, the net zero 2050, they call it, which is consistent with 1.5 degrees. So these are the scenarios that we sort of want to follow. Somewhat coincidentally, I guess, it goes down about the same rate of emission reductions last year. So more or less, we need to be reducing emissions globally at 5+% per year. And these are pretty radical transformations. It's very abstract when you show it as a figure, but there's no way that you can use trading to get out of this. There's no way you can offset out of this. The only solution here is you stop burning coal, oil, and gas. That's the simple answer. And if you do burn some coal, oil, and gas, then you need some machine which sucks the carbon back out of the air. So these are pretty radical transformations of the energy system, which we often lose when talking about these abstract numbers and figures and so on. The IEA does get some critique. Many will hear that various things about the IEA, but if you compare the International Energy Agency, IEA, with IPCC and the scenarios they assess, they're pretty much consistent. So the light blue lines here are 1.5 degrees from the IPCC special report on 1.5 degrees, and you see IEA, IPCC, they're rather similar. They're in the same ballpark. Generally, the IEA is more conservative on things like carbon capture and storage, which will surprise many people. It's also pretty conservative on, has deeper reductions in some fossil fuels, oil in particular, compared to many IPCC scenarios. So the IEA is in no ways inconsistent with IPCC. Some of the confusion comes in because many people think about the IEA as this light blue curve, the stated policy scenario. That's where we're heading. Where we want to go is the green lines. There the IEA is very much consistent with others. Just to finish up, an example of oil. It's a little bit abstract. I've tried to keep the figure relatively simple by showing a minimum number of lines here. This figure shows oil consumption. Basically, we have no climate mitigation at the top, some climate mitigation with the scenarios in the middle, and the bottom, if you take the purple line there, that's consistent with around about 1.5 degrees. The black line right at the bottom is sort of roughly what would happen if there were no new oil fields, if you like. So you just basically use the oil that we already have, but don't go expanding into new areas and so on and so forth. So this is sort of interesting in many respects. So we live in a world where we're heading, let's say, we have some policies already. So you wouldn't expect that we're going to follow the top lines here, but somewhere in the middle. That would maybe take us to 2.5 or 3 degrees. Then we want to go much deeper down to these blue or purple line in this figure. So we should already see some change in what's going on in oil and gas companies. So if they're serious about what they're doing and what they're saying, since we've shifted already from a no policy situation into a situation where there's some mitigation, we should see some change in investment behavior from oil and gas companies. But also, if these companies are serious about 1.5 degrees, we should see even a bigger step change, moving away from even less investments in oil and gas, because these scenarios are clearly showing that we're going to need a lot less oil and gas in the future. So an interesting question to ask or to look at is, how have investments changed in the sector in the recent years, and how will they change in the near term as they sort of clamp down on climate policy? So this is sort of my last slide, more or less. It's in particular reference to the previous figure, but it also acts as a very good summary or conclusion to the use of scenarios in sort of climate risk assessment. So scenarios are constructed in a cost optimal way. They're an economic model. They're sort of a theoretical construct in a sense. Just to summarize, everyone behaves as they should, driven by whatever the economy says they should do, and whatever costs say they should do, and so on and so forth. There's no bumps, if you like, in these scenarios. Donald Trump doesn't get elected in these scenarios, only people that follow through on climate policy aggressively and so on. So they're very idealized. That's important to remember. I haven't talked so much about carbon dioxide removal or negative emissions, where we sort of use technology to take carbon back out of the air. But these scenarios use this technology at a pretty significant scale. If that technology doesn't come to fruition, then there's less space for oil and gas, less space for coal, and so on. Scenarios generally do poorly at new technologies. This is IEA, IPCC, everyone, pretty much. Solar, wind, batteries, electric vehicles, and so on. They come faster than many are assuming. And this is something that may well continue into the future. So there's risks associated with that. And if you go back and think about the original figure I showed, the plethora of scenarios, there's 500 scenarios there. Within that figure, I can pick out all sorts of scenarios that will fit very different narratives. So there's a lot of wiggle room, if you like. So it's easy to find pathways that will justify a story. So you need to assess your risk across a range of scenarios just to make sure that you're not taking in an outlier. And importantly, the last point here, scenarios are just one piece of the puzzle. Scenarios aren't going to completely do your climate risk assessment. You need to bring in other elements of information that sort of supplement the scenarios in different ways. So I'll finish up there. I'll just sort of remark very quickly at the end. We've got a lot of activity going on in this space. In 2 weeks' time, 17th of February, 3 weeks' time, 4 weeks, we have a report coming with the UNEP Finance Initiative, a little bit more discussion about integrated assessment models used to generate these scenarios. We have a new project going on for the next few years, which is pretty much targeted at stress testing and how you use scenarios for climate risk assessment, particularly on the transition risk side. So I'll finish up there and head back to you, Kristen. Thank you.